I'm Hubert Poznański. I'm a senior DevOps engineer on the production engineering team at Egnyte. And today I will share with you some knowledge about the Google Kubernetes Engine and Windows and how we deal with it at Egnyte. So with maybe some history with the increase in our environment, we needed to find a way to scale and increase the performance of some of specific application. And this was application that was very resource intensive in its original version. We knew from the beginning that it would not be easy and that we are doing something that was not popular in our company and our world. And there was a lot of things that we had to check out ourselves. It is well known that there are a lot of stereotypes in our world about the Windows and Microsoft environment. Before we decided to create the new feature, we had a solution based on Windows virtual machines, Microsoft Office. Everything was automated by a Puppet. There was a lot of Puppet code. It was hard to maintain. There was also the PowerShell. Deployment was based on the Ansible and the Jenkins. So you can imagine how hard it would maintain this setup. Because Puppet for the Windows, it's not something great. There was a lot of issues with it. So and of course, when we are doing a Windows update, everyone was scared. So we need to find a way how to scale it and how to create something new, which will be better. So we decided to create the Kubernetes cluster based on the Windows poole and the Egnyte. So the first wing we was started. It was thinking about how to create such a cluster. It was something new for us. Until now, we didn't have much experience using Windows at this scale and on the top of that Kubernetes. Generally, we create the cluster using the Terraform module, which was our own project. It was created by Mateusz Kubacek, one of our DevOps engineer. The module itself, we create everything from the creation of basic firewall rules to the configuration of auto-scaling. And in addition, we have a module to create a service accounts for the workload identity purposes. It was handling also the network-specific things like IP addresses for the network load balancers and also the network load balancers. So it's a big module. It's a big module. So you can see the example on the screen how we create the cluster with this module. Cluster creation itself is not problematic. However, until this project, our cluster were based on Linux. And as I mentioned before, we didn't have much experience in solution based on the Windows environment. Some of us was the sysadmins in some part of the career, but we are not aware how much features are not supported compared to the Linux-based. For example, printable nodes, Windows nodes, have recently become available. Same situation with the workload identity. Particularly interesting was the meeting with the people from the Google responsible for the Google Kubernetes engine. We asked them a question, hey, we have a problem with printable nodes, and They are not behaving correctly. They look at us strangely, as it turned out that there is no support for this functionality at all, and they were surprised that we use it and it's working. Maybe it's not behaving correctly, but it's working. Yeah, it's easy, but it's not easy without some features. So why we need a separate cluster for the Windows pool this particular application on the Windows? So as you can see on the screen, for Google Kubernetes Engine clusters, the following features are not supported with Windows node pools. And there are a few features that hurt us the most. First off is IP masquerading, is a form of network address transition used to perform many-to-one IP address translation, which allows to multiple clients to access a destination using a single IP address instead of many. And a Google Kubernetes Engine cluster use IP masquerading so that destination outside of the cluster only receives packets from the node IP address instead of pod address. So it's very useful, and it's important in case when you have large environment where you use a lot of IP addresses. Second is network policies. It's important from the security side. Because network policies specify that network traffic that pods are allowed to send and receive. So network policy logging lets you record when a connection is allowed or it's denied when and lets you record when this disconnection. Using a network policy login, without it, we can't verify that our network are working as expected, understand which pods in your cluster are communicating with the internet, understand which namespace are communicating with each other. And from the security side, the most important is that recognize a denial of service attack. So, as you can easily guess, it's turned out that it will be the big adventure for us to set up properly the Kubernetes cluster with the Windows node pool. And there is a one big advantage of the Kubernetes, as everyone knows, that it's dynamic, but it's not there with the Windows. As you can see on the next slide, the build of the node pool based on the Windows, it takes 41 minutes. Sometimes it's longer. We knew what we were up against, but we were still surprised that it's so long. Here you can see the compared to the container OS node pool creation. It's just a couple of minutes, 3 in this example. After we created the clusters, we had to create Docker images somehow. At first, I tried to write something like a cloud builder for Docker image myself. There was a lot of PowerShell code, and it wasn't deterministic, but it even worked. But then I found the solution on the Google Code Platform GitHub. It's turned out that there is a lot of cloud builders created by the community, and there is also for the Windows. So you can find it everything on the link. I put it on the top on the slide. You can find there a lot of solutions for different platforms and languages. So there is one problem. It's turned out that For our application, we cannot use nano images, which was quite crucial due to its size, because the nano images is 200 megabytes, and the core images which we use for our application is 2 gigabytes. So it's larger. As we can see on this slide, building an image based on the Windows core isn't very dynamic, but as I mentioned, we couldn't use the nano version for a variety of reasons. That doesn't change the fact the image build works. Everything works. It's just much less dynamic than its Linux counterpart. So, what tools do we use for the deployment? It's more standard part of this presentation, because it turns out that Windows-based environment, we can also use the Jenkins, Helm, Helmsman, GitLab hooks, everything that you use on a daily basis and without major change for the Windows purposes. So in our case, we use the Helmsman for creating the charts for our application, and Jenkins is doing the rest of the work, is deploying on our clusters the services. So for high availability things, we used most of the things that Google Cloud provides. We use a multi-zone setup that protects us from the outage of one of the zone. On the front of services, we have a Ingress AJ proxy, which is our main load balancing solution for our services. Also, we configure some auto-scaling theme with our module. On the application side, we use the Kubernetes features like node affinity and node anti-affinity. So there's nothing special for the Windows environment. Affinity at a particular level indicates that all pods belong to the same service, are scheduled on the nodes that belong to the same level. Anti-affinity at the particular level indicates that all pods that belong to the same service are split across the nodes that belong to the same level. This ensures that the application is well spread for high availability purposes. The scheduler tries to balance the service pods across all applicable nodes as evenly as possible. So for the monitoring purpose, we use a rather standard set of tools. Prometheus to collect the metrics as a standard for our application, for our environment. Prometheus is deployed on each cluster separately. We use Grafana for visualize these metrics. Elasticsearch Stack to collect metrics from the application, as well as the cluster also. Of course, we use the Kibana to work on these logs, Logstash, bits, audit bits, and Isinga, where we have end-to-end checks. So on this slide, you can see the example from our Grafana dashboard, which visualizes metrics from running replicas, average CPU usage per container, average CPU usage by pod container, CPU throttling per multi-coud container. So it's very useful in daily basis. There is some missing metrics from the Windows node pool, like the network I/O pressure. So this is some statistics from our Elasticsearch stack, EMS. It is not small, quite large parts of it are logs from our Kubernetes environment. So as I mentioned before, there's a couple of things that are missing for the Windows node pool. One of them is that Elastic doesn't provide the dedicated Docker image for the Windows, for the file bit. So we had also to create ourselves. And here you can see the difference between the file bit usage, resource usage for the Linux and for the Windows. So for the alerting purpose, we use the Prometheus, which is triggering Slack and PagerDuty and Isinga. Everything we have in the code as a rest of the environment. So really, it's possible. Yes, it's possible, but there is one thing that left is a Windows update. So Windows updates are disabled for the Windows Server nodes. Automatic updates can cause nodes restart in unpredictable times, and any Windows update installed after a node start would be lost when the node is recreated by Google Kubernetes Engine. Google Kubernetes Engine makes Windows updates available by periodical updating the Windows Server nodes image used in the new Google Kubernetes release. Of course, there can be a delay between when Windows updates are released by Microsoft, and when they are available in Google Kubernetes Engine. When critical security updates are released, Google Kubernetes updates the Windows server's image as quickly as it's possible. But there is one tricky thing. There's something named Windows Server Container Version Compatibility requirements. It means that your container image may need to be rebuilt to match the Windows Server version for a new Google Kubernetes Engine version before upgrading your node pools, because it has to be matched. Version of Docker image and version of the node pool image. So right now, maybe the summary. Problems encountered. Yeah, there is a lot of problems everywhere. Right now, our biggest problem is a service mesh. Officially, Istio is not supported. We will probably be forced to use or maybe try the open service mesh, which is officially supported by Microsoft. We hope that it will work, but it is too early to say anything about it. There is a couple of solutions for it, but we don't want to creating something separately for the Windows node pool, for the Windows clusters, and for the our Linux-based environment, because if there will be more solution, it will be more hard to maintain, which is normal. So was it worth it? Was it really hard? Honestly, it's hard to say, because I hope I showed this presentation. Because I showed this presentation, I tried to show that it was not the easiest task. Certainly, Windows and Kubernetes still have a lot of drawbacks. Like I mentioned before, there is some missing features like network policies, IP masquerading, and let's see one more time on this slide. So we can't use GPUs for machine learning purposes. There's no data plane in version 2. So this is still something new, and we have to be aware of it. Was it worth it? Yes, it was, because the services worked, and I think it's the most important thing, because if service works, our clients are happy. Cluster works, everything worked, so it's still something good for us. I think it's all from my side. Maybe there is some questions. Some statistics from our Kubernetes setup. Our main setup, which is based on the Linux, it's almost 100 nodes, almost 2,000 pods. We used almost 2,500 vCPU and almost 3,000 RAM, so it's not small setup. And compared to the Windows setup, we use for now only 50 nodes and almost 200 nodes, and less CPU in the main setup than main setup and RAM, but it's still not small environment. Maybe I will tell something what is Egnyte, because I'm telling about the service for our client, but it's also important that what we are doing here. So Egnyte, it's a cloud for platform for the enterprise for synchronization and sharing, as well as a content and data governance for business customers. We offer storage, collaboration, a lot of features, sharing capabilities with our cloud infrastructure. And it's all. Thanks.